Sedimentary rocks. So on the table, we have various samples of sedimentary rocks. $20 in all. You notice that some of these rocks have nice bright pink papers that says react to hydrochloric acid. So in a test situation, I will simply do this. I will tell you that the rock reacts to hydrochloric acid. So you have 20 samples, and you can see there's a variety of rocks here and sedimentary rocks. Sedimentary rocks are much more simpler to identify than igneous rocks. Igneous rocks are probably the most complex, weird terminology, where sedimentary rocks are a little bit more standard technology, things like sandstones, And so when it comes to identifying sedimentary rocks, there's basically 3 classifications of them, and only 3. So the 3 classifications are clastic, or sometimes known as detrital. So clastic rocks simply means these are fragments of other rocks, grains. So clastic and detrital are 2 words. Ditris is a Greek word meaning dirt. So these are rocks that are fragments, pieces, chunks of other rocks. So all sedimentary rocks basically originate from the weathering of other rocks, unlike igneous rocks, where all igneous rocks originate as magma. Then there's chemical rocks. These are formed in water, in a water-rich environment. So these are rocks such as things like limestones, dolostones, phosphoriferous limestones, chalk, coquina. And then there's the biochemical classification, and this is ones that are rich in organic material. And the only one we're going to see is coal. And then next week when we look at metamorphic rocks, we'll see a different version of coal that has been subject to heat and pressure. So basically, we're going to use 2 charts here. Chart number 1 is for grain size. Chart number 2 is no grain size. So what you look at first when you look at sedimentary rocks is you ask yourself, can I see grain size? So if you see grain size, then we're on chart number 1. These are all rocks with grain size. So they range from gravel all the way down to clay. So gravel is the more coarser, the larger size material. And then clay is the finer grain material. When you get into chart number 2, this is the chemical / biochemical. These are rocks that are formed in a water-rich environment. Things like limestones, phosphoriferous limestones, are formed underwater. Limestone is formed in ocean waters that are very warm, very tropical. The phosphoriferous limestone has fossils. Coquina, a rock full of fossils. We'll see chalk, we'll see travertine. We're going to see salt rock. So sedimentary rocks are much more easy to identify. So we're going to use our lab manual. And so I would fill this out to its completeness. I kind of skipped around a little bit just for illustrative purposes. So the example here. The rock is chemical. That means there's no grain size. So you put grain size none. The sedimentary composition is calcite mud. You can get that off of the charts. Special property, in this case, there were fossils. So then the name of the rock is phosphoriferous limestone. So we have far less qualifiers to name the sedimentary rock. So it's much simpler. So what I'm going to do is I'm going to go through each sample. I'm going to tell you if it's clastic, detrital. So I'm going to go through every one of these. And I kind of put these in a specific order. So number 1 is the coarsest rock we're going to see. This definitely has grain size. And you can see that the fragments here are rounded. They are gravel size. So for the texture, this is a classic rock. For the grain size, gravel. For the composition, you can just put gravel. Special property, you can see they're rounded, well cemented together. Moving on to number 2. Very similar, but this has more angular fragments. So this too is a clastic rock. So number 2 is clastic. Grain size is gravel. The sedimentary composition will be more angular gravel, and the special property would be angular. Number 3. This is a fine grain rock, but it is a clastic rock. This rock is also clastic. They're both clastic. They both have sand-sized material. So 3 and 4 are both clastic. The grain size for 3 and 4 is going to be sand. Now, what's the difference between the red one and the white one? So the sedimentary composition is quartz sand for number 3 plus iron oxide or hematite. That makes this a little bit different name. So this has iron oxide in it. It is a red rock consisting of sand grains. Number 4 is a white rock consisting of sand grains. And for special property on this one here, I would put down very well rounded, very well sorted. So well sorted means everything's the same size. Moving on to number 5. Number 5 is also a classic rock. Its grain size is going to be a coarser sand. The special property is going to be poorly sorted. So this is poorly sorted, meaning that there's a little bit of hodgepodge of everything in there. So it's not a clean, wind-blown rock like 3 and 4 are. It's not well sorted. This is poorly sorted. So this is going to be clastic. Grain size is going to be sand. The sedimentary composition is going to be clay and sand. Moving on to number 6. This is also a classic rock. So you can see it's classic because it has fragments of other rock in it. The grain size again is going to be sand, even though there's larger fragments in here. And these larger things is what you're going to put on your special properties and your sedimentary composition. So for sedimentary composition for this, you're going to put down quartz plus K-spar. It's full of potassium feldspar. And that makes it a very special rock. So number 6 is a classic rock. Grain size is sand. Sedimentary composition is quartz sand plus potassium feldspar. And the special property is that this has potassium feldspar in it. Number 7. Number 8. Number 9. And number 10 are all basically the same rock, but they're different colors. They're different colors because they're formed in different environmental conditions. So all 4 of these rocks, 7, 8, 9, and 10, are all clastic. The grain size is going to be clay. The grain size for all 4 of these rocks is clay. The sedimentary composition is clay minerals. That's the sedimentary composition. Silt, clay may contain fossils. Often rocks like this do contain fossils. These are nice layered rocks. So these are layered. And they form in different environments. Sometimes they'll form in tidal flats. Sometimes they get organic material in them, that they have some oil in them. So all 4 of these rocks are clastic. The grain size is going to be clay or silt. We're not going to really split hairs with that. The sedimentary composition is primarily going to be clay minerals. And the reason I have 4 different varieties, 4 different samples of the same rock. It's just to show you the different colors. So greenish color rocks like this form in deep, deep water environments where there's no oxygen. This was a shallower water environment where water and land kind of meet. This had plenty of oxidation. This had a lot of organic material in it. And that basically ends the classic sedimentary rocks. We now go to the other chart. So we're going to look at rocks number 11. So I did a division here. All of these rocks are going to be found on chart number 2. These don't have a grain size to them whatsoever. So this particular rock here has no fossils in it, gray in color. So its composition, so its grain size, the texture is going to be chemical. The grain size is going to be none, no grain size. Sedimentary composition, since it reacts to hydrochloric acid, anything that reacts to hydrochloric acid is going to contain calcite. So in this particular rock here, you put acid on it, and you can see it fizz, even though the acid's running off, but it's fizzing away. So on a test situation, I will put reacts to acid so you know. So this rock reacts to acid instantaneously. Its sedimentary composition is basically limestone. Special property, reacts to acid instantly. Number 12 also reacts to acid, but you have to scratch and break the surface. There was a mineral that had this same familiarity, same concept. So number 12, you have to scratch this in order to get the reaction. But since it does react, it also has, as its sedimentary composition, is going to be calcite. So these rocks here, all of these rocks from 11 to 20, all of them have the same texture. They're chemical. The grain size is none. We mostly look at sedimentary composition here. Number 13, no grain size, very soft. You loved it as a kid. It does react to acid. You can scratch this with a fingernail. You can write on sidewalks with it. Its chemical composition is calcite, so it's a chemical rock, no grain size. Special property is that it writes on sidewalks and everywhere else. Number 14, this rock contains some fossils. It too reacts to acid. So this rock reacts to acid. Since it reacts to acid, it contains calcite. Formed in the bottom of the ocean. The difference with this rock is this contains fossils. So, no grain size, chemical rock with fossils, forms in the oceans. This rock we see right at the interface between the ocean and the beach. And this is basically a clustering of broken shells. So this is a whole bunch of broken shells, kind of white color. So this is like somebody took a bunch of broken seashells and glued them together. And that's exactly what this rock is. So this does not have a grain size. This is a chemical rock. And we see this right where the beach sand and the ocean meet. You'll see little clusterings of shells. These become buried, cemented together into a rock that's on our chart here. So all of these rocks from 11 to 20 are going to be found on this chart here. So if you look at the descriptors of these rocks, all right, rocks number 16, 17, and 18 all have one thing in common. They're all chemical rocks, just like the other ones. They have no grain size. But all three of these rocks are hard. How hard? They'll scratch glass. Their hardness is a 7. And they're all the same. The difference is that because of color, we give them different names. So this one here is gray. Hardness is 7. Its sedimentary composition is quartz. So its sedimentary composition is quartz. Number 17, darker one, sedimentary composition, quartz, no grain size, chemical. Special property, very hard, scratches glass. And the same with number 18, which is a red color one, the prettiest one of the three. But all three of these rocks are basically the same rock. 16, 17, and 18 are all three the same sedimentary rocks, and we discussed this in lecture. 19 is a biochemical rock. It's dark. So it has no grain size. It's a chemical rock. But its sedimentary composition, a little bit different. Carbon. So it has mineral composition of carbon, layers, black color, forms in swamps. Alfred Wegener recognized this one. And then, last but not least, is number 20. This might be a little bit tricky. You say, well, wait a minute, I think I see grain size. This really throws a lot of people off. The dead giveaway about this particular rock is, it tastes like salt. And so this is like the mineral halite, and that's what this chemical composition is, NaCl. And this is the rock version of it, which means it's not pure. So halite is pure. This has some impurities in it. So 2 charts. You look at clastic versus chemical. If it's a classic rock, you break it down into the grain size. You break it down into silt / clay. And the difference between silt and clay is clay tends to be more smooth. Silt is a little more gritty. Or we have sand size. Sand size varies. These are poorly sorted, which means that the grains aren't all the same size. These 2 sand size materials are very well sorted, which means that all the material is of the same size. And then these are the gravel size, rounded versus angular. So again, in Canvas, what I will do is I will have for 1 through 20, you'll have a multiple choice, 1 correct answer, fill in your lab, use the charts, mark on the charts for the ones that we've had. Basically, we're going to see every one of these in the clastic and in the chemical. I'll tell you the things that we're not going to see. We're not going to see rock gypsum. We're not going to see chalcedony or travertine or oolitic sandstone. Everything else we'll see. So we'll see a limestone, phospholiferous limestone, dolostone, coquina, chalk. We'll see salt rock. We'll see jasper, chert, flint, and coal. And so those are the rocks that we'll see in the chemical side. On the first chart, we'll see one of everything will be there. So listen to lecture. We'll go through this stuff in lecture and then throughout the lab here. And hopefully this will help you identify with ease sedimentary rocks, which I think are much straightforward, much simpler. So remember, sedimentary rocks are fragments, pieces of other rocks. Next week, when we look at metamorphic rocks, We're going to take most of these rocks and we're going to combine them. There's very few metamorphic rocks. So that'll be the next lab. And then we'll start reviewing for the rock and mineral identification lab.